Hi, welcome to No Code Machine Learning app. In this video, we are going to look at a regressor algorithm called boosted tree regressor algorithm. So let's begin. This is the interface for training a boosted tree regressor machine learning algorithm. We begin at step 1 to select the training data file, which must be in .csv or .json format. So let's do that. We are going to use as part of our sample data NYC taxi fare data, and we are extremely grateful to the authors and the organization for making the NYC taxi fare data available for both training and research. So we select the taxi fare training data file here, and the training data file is fairly large. It has about slightly more than 1 million rows of data in this file, and it's in .csv format. So we open this file. So we have loaded the taxi fare training.csv file. One note on the simple structure of the acceptable .csv file is that the first row of the .csv file must contain the column names. For example, here day, outlook, temperature, humidity, wind, and play tennis. Then we have rows of data. Play tennis is the target column, and the target column data type for all the regressors in the no code machine learning app must be of either integer or double data type. No string is allowed. And you can see the simple structure of the .csv file that's acceptable to the no code machine learning regressor algorithms. In next step, we have the option to choose all the features from the training data table, and we can see all the features in the training data table at this time: fare amount, passenger count, rate code, trip distance, payment type, trip time in seconds, and vendor ID. As part of this example, fare amount is the target column that we would like to predict using these features. No code machine learning app also gives you the option to clear that selection and choose to see the available features from the training data table and create a custom feature set for training the boosted tree regressor. In this case, we are going to select fare amount. We are going to select payment type. We are going to select passenger count, and we are going to select trip distance. So we are not selecting all the features available in the training dataset. We could have done that over here. But here we would like to custom select the features, and this option gives you the ability to select different combination of features and see which feature set provides the best trained boosted tree regressor for your dataset. Having chosen these, again, just as a note, fare amount is the target column that must also be selected along with the other features. Once you have done that, go to step 4. Here, just confirm the selection so the app knows that these are the features you'd like to use as part of the training and evaluation. Next, we have the option to automatically select a random 80-20 split of the training data file. We have a fairly large data file, slightly more than 1 million rows of data. So we can easily select step 5. In step 5, the app will automatically divide the training data file into 80% for training and 20% for evaluation. And the app also ensures that the features that are selected here, passenger count, trip distance, payment type, and the target column fare amount, matches exactly what was selected training part of the app. So your fare amount, passenger count, trip distance, and payment type provides the visual confirmation to make sure that we are very consistent in terms of training and evaluating our boosted tree regressor. Once you have done that, we move to the next step. One other note is that you do have the option to clear this selection as well and go with a completely different evaluation data file if you choose to do so. And the app will ensure that whatever feature sets we have chosen during training over here, a custom feature here is also selected here, even though we might be choosing a completely different evaluation data file. So once you have done that, you can see list of hyperparameters for which you can provide custom values to train the boosted tree regressor. This is meant for more of an advanced user who would like to be able to experiment with different hyperparameter values to get and to obtain the best trained boosted tree regressor machine learning model. We also provide some suggested hyperparameter values, and you can use these as well. So we are going to begin with max depth 6, minimum child weight 0.0, minimum loss reduction 0.0. Then we have random seed 42, column subsample 1.0, early stopping round 1.0. Then we have max iteration of 10. Then row subsample 1.0, step size 0.3. Target column name in our case is going to be fair amount. That is what we would like to predict using the boosted tree regressor. The fair amount target column name must exactly match with the fair amount target column in the training as well as in the evaluation data file. So please ensure that the spellings are exactly as they appear in the training data file. Once you have done that, we are ready for training and evaluating the boosted tree regressor. Let's do that. It's a training and evaluation to be completed. Now let's look over here. We have the boosted tree regressor performance metrics. We have the training metrics, validation metrics, and evaluation metrics. Under training metrics, we have the max error and RMSE, validation metrics, max error and RMSE, and evaluation metrics, max error and RMSE. And you can assess these values to see how well your boosted tree regressor is performing given the dataset and the hyperparameter values that have been set here. As we mentioned earlier, this is meant for more of an advanced user who would like to do multiple experiments with the hyperparameter values to see which set of parameter values provides the best trained boosted tree regressor. And you have the option to save these metrics in a .csv file for further analysis. So we can save the performance metrics as part of this app. So we're going to save the prediction performance metrics. We're going to call it boosted tree performance, and we're going to save that file. Let's see what we just saved. Let's open that folder. We're going to sample data, then we are NYC taxi data, and then we look for performance matrix. Under prediction, we have boosted tree performance file, and we open that using numbers. It's a fairly simple file. It basically is tagged with boosted tree performance, and we have evaluation maximum error, validation RMSE, training maximum error, training RMSE, evaluation RMSE, and validation maximum error. And you can see that these numbers are available if you would like to run multiple training sessions using multiple combination of hyperparameters or different training data files to get the best trained boosted tree regressor. And you can save these results for each training session and be able to perform your own analysis to find out the best boosted tree regressor for your dataset. In the next part of the app, if we are happy with the trained boosted tree regressor, we can now predict using this trained machine learning model. So we can select a data file that has not yet been used for prediction. So we can select the data file for fair prediction here. So we have a file that has the feature values, but we'd like to be able to predict the fair amount. So we open that file. Notice here that the app automatically selects passenger count, payment type, trip distance, as the features for predicting the fare, and you can see those features match exactly the features we used for training the machine learning model: passenger count, payment type, and trip distance. This visually ensures and confirms for us that the features selected from the prediction data file matches exactly what the trained machine learning model is expecting, because those are the features we used for training the machine learning model. So once we have done that, we are ready for using the trained machine learning model to predict the fare amount. So we go to step 10. It's somewhat of a fairly large file with about. So the prediction is complete, and we can save the prediction result in step 11. So let's save the result. We are going to save the result in the prediction folder. So we are going to call this boosted tree result, and we're going to save that in this folder here. So let's open the folder, open the file to see what we just saved as part of our result. So in the prediction result, boosted tree result, we open that using numbers. And here you can see the boosted tree result file and the features that we have selected: passenger count, payment type, trip distance, to predict the fare amount. And here is the result of that prediction. And you can see it's a fairly large file with rows and rows of data that have been used for predicting the fare amount of the NYC data. So again, you're able to save the result. You can do further analysis, data visualization of the result with other software, including numbers and Excel spreadsheet that can read a .csv file. Next, since we are happy with the performance of our boosted tree regressor, we would like to be able to save that machine learning model for use in developing intelligent iOS, macOS, watchOS, or Apple TV apps. So let's do that. We are going to name this model predict fare amount, and we specify the author name, and the license is going to be MIT, and the version is going to be 1.0. So we are going to save the machine learning model as a .ml model file, and we're going to save that in a folder, and we're going to call this ML model predict taxi fare amount .ml model, and we're going to save that. So let's take a look at what we just saved. So here is the folder, and here is the file that we just saved. Let's open it with Xcode. As you can see, it's a standard ML model file. It's the name of the machine learning model is predict taxi fare amount. The name of the author, license. Then it shows the input type, passenger count, trip distance, payment type, and the fare amount as the output. So this can be used for developing intelligent macOS, iOS, watchOS, or Apple TV apps, depending upon what it is that you are trying to develop. But the ML model file is available for further application development. And to recap, with the boosted tree machine learning algorithm as part of no-code machine learning app, we selected the taxi fare training.csv file, which has slightly more than 1 million lines of rows of data. We have the option to select all the features. In this case, we selected custom features, and custom features allows you to experiment with different feature combinations to see what combination of features gives you the best trained machine learning model. You confirm that selection of features. In the next part, you have the option to automatically split the training data table into 80% for training and 20% for evaluation. you have a visual confirmation of the exact same features and target column being selected as well. You also have the option to clear that selection and select the evaluation data file that is different from the training data file if you choose to do so. Once you have done that, this is, as we said, is for more of an advanced user. If you'd like to experiment with the specific hyperparameters to train the boosted tree regressor, you can do that. We also provide some suggested hyperparameter values, and you can begin with those as well. And once you go to step 7, you can train and evaluate the boosted tree regressor. Then you have the training metrics, validation metrics, and evaluation metrics, providing assessment about the performance of the boosted tree regressor. If you're happy, then you can also select a data file that has not been used for our prediction yet, and you can select the data file. The app ensures that only the features that were selected for training the machine learning model are the only ones that are selected for prediction as well, to be consistent. Then you can run the machine learning model on the prediction dataset, and then you have the option to save the result, and you also have the option to save the machine learning model for further intelligent iOS, macOS, watchOS, or Apple TV app development. We hope you enjoyed watching this video, and thanks for taking the time